You're welcome to day 40 of 50 days of tutelage. In today's class, I will be discussing trigonometry with you. This is going to be the first part. In our next math class, I'll talk about trigonometry 2 as well. So what am I covering into this class? I'm going to be talking about measurement of angles. How exactly do we measure angles? I'll be talking about the SOH CAH TOA. I'll be talking about the SOH CAH TOA, and I'll be talking about special angles. So these are the things I'm going to be focusing on in this class. So let's go to measurement of angle. How do we measure angles? Now, there are so many ways that we measure angles based on different occasions, based on whatever we are doing at that point. So there is the way we measure angle when it comes to bearing, and there is the way we measure angle, like actual angles. So we have to look at this right here. Yeah, we have to look at this right here. And in this place, I'm going to be discussing about the four quadrants that we have in trigonometry. But the first thing you need to know is that if this is representing y-axis, and this is representing x-axis, or this is representing vertical axis, and this is representing horizontal axis, angles are usually measured starting from the positive x-axis. So angles are always measured starting from the positive x-axis. That's the first thing you need to know. And secondly, angles are measured counterclockwise. They are measured counterclockwise. So which implies that if I ask you to measure a certain angle now, you start from x and then you go counterclockwise in this manner. So that implies that if you go that like this now, when you touch this particular point, you have completed an angle of 90 degrees. When you move again further and you get to this point, you have completed an angle of 180 degrees. When you go to this place, you have completed an angle of 270 degrees. And by the time you come back to this place, you have completed a total angle of 360 degrees. So if I ask you to take a measurement of angle 220 degrees, all you have to know is that angle 220 degrees is something beyond 180 degrees, but it is not up to 270 degrees. So therefore, angle 220 degrees will fall somewhere around there. So you draw a line out of that and then you say this is actually 220 degrees. So that is exactly how you take a measure of angle. When it comes to bearing, I'll talk about that much later, but let's focus on the real thing for now. So, but this whole thing, we actually like separate them into different quadrants. So for as you can see here, we have first quadrant, we have second quadrant, we have third quadrant, we have fourth quadrant. Meaning that as this guy is divided into four chambers, and we are measuring any angle, this is the first place that we find ourselves. So this is the first quadrant, this is the second quadrant, and this is the third, and this is the last chamber that we'll find ourselves. Then we continue the whole process again. So I'm going to extract this out now and then make it a little bit bigger. Okay, so back to this our first quadrant and all of those things. So what we observe here is that we have from here to this place, we have angles that are between 0 and 90 degrees. So this is first quadrant. And what do we have there? We have angles that are, so let's say we are using theta as our angle, angles that are less than, that are more than 0 degrees, but they are what? They are not up to 90 degrees. So angles that fall between 0 and 90 degrees. That's our first quadrant. Our second quadrant contains angles above 90 degrees, and then they are not up to 180 degrees. Of course, you know that these angles like these are called acute angle. So what are these second quadrant angles called? Let me know in the comments. Now we have the third quadrant. We have the third quadrant. Third quadrant is from 180 degrees to 270 degrees. And we have the fourth quadrant. We have the fourth quadrant that is from 270 degrees to 360 degrees. So this is the first thing we know about each of these quadrants. We know the nature of the angles that are there. We know like their value, their range of value. Now that we know this, there are trigonometry ratios. And these trigonometry ratios, we have like 6 of them, 3 major ones, and then the remaining 3 are just inverse. So I'm going to come back to this much later to do more of the things that we need to explain there. So, but I've been able to explain to you that we measure angle counterclockwise and we always start from the positive x-axis. So let's now go to the trigonometry ratios now. We'll come back to this particular four quadrants later. So let's talk about trig ratios now. The trig ratios. So the concept of trigonometry itself is simply, in meaning, it means measurement of triangles. Measurement of triangles. And we have the different types of triangles. I'm not here to discuss those types. So we have the scaling triangle. So let's say this is a scaling triangle. It's such that its sides are not the same. Its sides are not the same. So if this is this, you have this, you have this, you have this. We have the isosceles triangle. The isosceles triangle, the way it works is that it has two of its sides to be the same. So two of its sides are the same. That's for the isosceles. So, and then we have the equilateral triangle, which has all its sides to be the same. That does not look like a triangle. Anyways, this is just a sample. So let's say this is an equilateral triangle. All the sides are the same. 1, 2, 3, all the sides are the same. Now, these are the three major types of triangle that we have. I know somebody would say, what about right angle triangle? Yes, we have right angle triangle. Just know that right angle triangle also falls within these three. A right angle triangle can either be scaling right angle triangle or an isosceles right angle triangle. So, but for right angle triangle, the major thing about them is that one of their angles is actually equal to 90 degrees, and which is the angle that we have here. The major thing about right angle triangle is that one of the angles there is 90 degrees, and the rest will actually sum up to be 90 degrees as well, because sum of all the angles in a triangle is 180 degrees. So now let's begin to do a little bit of identification. So if this is a right angle triangle, the first thing we know is that it has a longer side. The longer side is regarded to as the hypotenuse. The longer side is the hypotenuse. Take note of that. Now, these two other sides, the one here and the one right here, I know that many people would like to call this place the opposite, and many people would like to call this place the adjacent, but that's not really the way it works. It depends on where your angle is. So if your angle is here, and let's say your angle is theta, then whatever side is that is directly facing that angle is what you regard to as the opposite side. So this is the side that is facing this angle, that is your opposite. And the side where the angle is made with the hypotenuse is called the adjacent. So you need to be able to identify your adjacent and your hypotenuse properly. So how do we now, what's now the trigonometry ratio and how do we actually deal with them? It is where we have your SOH CAH TOA. We have SOH CAH TOA. SOH CAH TOA. So what is SOH CAH TOA really representing? It's representing the major three trigonometry ratios. So we have the sine of an angle. S represents sine of an angle, that's sine theta. C represents cosine of an angle, that is cosine theta. And then T represents the tangent of an angle, tan theta. And so what you notice from here is that each of these, they have been marked by their trigonometry ratio already. They have been marked by their trigonometry ratio. For instance, the first one, which is SOH, what you notice here is that SOH has this O and H with it. O represents opposite and H represents hypotenuse. So sine theta is the same thing as length of the opposite side divided by length of the hypotenuse side. Then cos theta, which is CAH, that is the ratio of the adjacent to that of the hypotenuse. And tan theta, that is the ratio of opposite divided by the adjacent. Now, one thing I want us to take note here is that this tan theta can actually also be written in form of sine theta and cos theta. Because if I say sine theta divided by cosine theta. That will be the same thing as opposite divided by hypotenuse divided by adjacent divided by hypotenuse. And if I try to switch this now, this will be opposite divided by hypotenuse multiplied by, so this will change and hypotenuse will come up and you have adjacent all the way down here. So this cancel out and you still have opposite divided by adjacent. So what does that imply? Since this is the same thing as your TOA, which is tan theta, that implies that we can also always express tan theta as the ratio of sine theta over cos theta. So that is SOH CAH TOA. So I'm sure you are all familiar with SOH CAH TOA. But there's another guy that you're probably not familiar with. That is the one we call the SOH CAH. So what is SOH CAH? These are just inverse trigonometry ratio. For instance, the first one, which is CHO, it represents what we call cosec theta. It can be shortened as CSC, cosec theta, which is actually the same thing as hypotenuse divided by opposite. So if you look at this now, sine theta was opposite divided by hypotenuse. Then cosec theta is hypotenuse divided by opposite. So that implies that cosec theta is simply the inverse trigonometry ratio of sine theta. Similarly, if we go down now, we have SHA. SHA is for sec theta. And sec theta is simply the ratio of the hypotenuse to that of the adjacent. And that is the inverse of cosine theta. So finally, we have the last one is cotangent theta. So cotangent, so which is shortened as cot theta, and that will be adjacent divided by opposite. Of course, that is the inverse of tan theta. So these are the major 6 trigonometry ratio. One is represented by the SOH CAH TOA, and the other is represented by the SOH CAH. So take note of these 6 trigonometry ratios properly. We got them from this right angle triangle here, using the adjacent, opposite, and hypotenuse. Of course, you know your right angle triangle very well. You know your Pythagoras theorem, and we've talked about that in previous classes. So let's proceed now. What do we do with all these things that we just learned? How do we really deal with them? Now, we need to know their behavior. These are called trigonometry ratios, and they are periodic in nature. What do I mean by they are periodic in nature? See, when you begin to evaluate them, of course, you evaluate them using an angle. So you cannot just say you are saying sine. It doesn't make sense. There has to be an angle. That is why you see that we are associating it with a theta. So sine of what? Cosine of what? Tangent of what? So when you evaluate all these values, what we realize is that this sine, cosine, and tangent, they are periodic in nature, such that when they take one value, so let's go back to this now. As you're moving from this place now, you're moving. When they take one value from this, when you get to the next quadrant, they look similar. The value that you get again, it looks similar as well. In fact, we see that most of the values that you will get for the evaluation of sine, cosine, and tangent of different angles, most of those values are well represented in the first quadrant. And the only thing that they probably would have differently is going to be their signs. One can be positive and the other is going to be negative, but they will be exactly the same value. In fact, if you go all the way to the fourth quadrant, you go to angles between 270 and 360 degrees, then you will still end up getting the similar values like those in quadrant 1. And let me now bust your brain. When I was actually much younger, when I first started learning trigonometry, I thought that the biggest angle we can have is actually 360 degrees. But well, let me not say unfortunately, I was just young and still learning. You can actually have angles that are bigger than 360 degrees. At least you can have angles like 780 degrees. I'm going to talk about them very soon. So let's now get right into this periodic thing that I'm talking about. So the first thing we need to know is that all trigonometry ratios are positive here. All trigonometry ratio, they are positive in the first quadrant. In the second quadrant, only sine is positive. That means that the rest are going to, they will be negative like that. But note, if sine is positive, its inverse will be positive as well. So sine and cosec, they will both be positive. When I mean the rest, I'm regarding to the three major ones first. SOH CAH TOA. Now, in this third quadrant, only tangent is positive. So that implies that cosine and sine, they are going to be negative in this quadrant. And for the fourth quadrant, only cosine is positive. Note, if they are positive, their inverse will be positive as well. So in the first quadrant, any trigonometry ratio will be positive. In the second one, only sine is positive. In the third one, only tangent is positive. And in the fourth one, only cosine is positive. So when you know this, you are practically on your way to properly evaluating the trigonometry ratios of angles. Then, after this, we need to now find a way to always make sure that we trap all the angles in the first quadrant. When I mean trap now, we want to really showcase the periodic nature that even though you have bigger angles, all of them still, they have a representative in the first quadrant. All of them still have a representative in the first quadrant. So how do we go about that? So the way we do that is that if theta is the angle that we are measuring, to take it back to the first quadrant, all you have to do in this place is just do 180 degrees minus theta. For this one, it is theta minus 180 degrees. For this one, it is 360 degrees minus theta. So what exactly am I trying to say? So what I'm trying to say is that imagine I ask you to evaluate something like cosine 220 degrees. So I told you that this guy will also have a value, a representation in the first quadrant. So how do we get the representation? The first thing you need to determine is that look at your 220 degrees. Which quadrant does 220 degrees belong to? I think that was the first thing I used as an example. So it belongs to, this is first, second, third. It belongs to the third quadrant. And so it belongs to the third quadrant. You can see that only tangent is positive in the third quadrant. So therefore, this cos is going to be negative. So you write negative cosine of that angle. Then when you are done with that, you then find the expression, the equivalence of these 220 degrees in the first quadrant by substituting that theta into this expression right here. So you do 220 minus 180. So what is 220 minus 180? Let me press my calculator just to make sure that I am correct. 220 minus 180, that gives 40. So that implies that cosine of 220 degrees is actually the same thing as the negative value of cosine of 40. That's basically what I'm trying to say. I will do one more, then you can go ahead and do some more yourself. If I ask you to evaluate tan, let me just say sine 150 degrees. So the first thing you do, you ask yourself is that 150 degrees, which quadrant does it belong to? That is the second quadrant because 150 falls between 90 degree and 180 degree. And so what we observe is that sine is positive in the second quadrant. So this will also be what? Sine. But now you substitute theta, which is 150 degrees, you substitute it here. 180 minus 150 degree, that is 30 degrees. So you have this. So what does that imply? Sine 150 degrees is the same thing as sine 30 degrees. You can always confirm these things on your calculator. So you can see the periodic nature of these trigonometry ratios now, such that no matter what the value of this whole thing is, you can always dump it back. So lastly, before I go to special angles, we have angles beyond 360 degrees. How do you measure, how do you really express angles that are beyond 360 degrees? For instance, I give you angle 780 degrees. I ask you to evaluate the maybe cosine of 780 degrees. Okay, I've used sine, I've used cos, let me use tangent this time around. So I ask you to evaluate tan 780 degrees. The first thing you need to do is that for you to measure angle 780 degrees, what it actually means is that you're going round and round in this place. When you go round like this, oh, that's not where you start from. You start from this place. You go round, this is 360 degrees. When you go round again, you have completed two 360 degrees, that's 720 degrees. Then you can now begin to do your remaining part. So after you have done 720 degrees, what is left for you to cover is 60 degrees. So that means that you go in this manner now. And this is what that angle will fall into. So the basic thing is that when you're measuring angle beyond 360 degrees, you are actually completing a loop, and the only thing that matters will be the remainder. So first thing you do is that you divide 780, you divide it by 360 degrees. As we can see, that is 2. Then you find the remainder. So what is the remainder here? 360 degrees in 780, that is twice, that is 720. So 780 minus 720, that is 60. So that implies that tan 780 degrees is just simply the same thing as tan 60 degrees. And it's just straightforward. So all you have to do is divide that thing by 360 degrees and find your remainder. So anytime you are beyond, and so for instance, if I ask you to find cosine of 400 degrees, so if you divide this thing by 360 degrees, that's just once. And what will be left there is 400 minus 360, which is 40. So cos 40 degrees, cos 400 degrees is the same thing as cos 40 degrees. And that's basically how you measure angles that are beyond 360 degrees. So let's talk about special angles now. So for special angles, I will be talking about the angle 45. So I'll talk about 0 degrees, 45 degrees, 30 degrees, 60 degrees, and I will talk about 90 degrees. So before I proceed with anything, I will talk about 0 and 90 first. So 0 and 90, we have that sine 0 degrees will be 0. In fact, this is the same thing as cosine of 90 degrees. So sine 0 is the same thing as cos 90 degrees, and both of them are equal to 0. Now, on the other hand, we have sine 90 degrees, which is 1, and this is exactly the same as cos 0 degrees. Please take note of that. Now, let's deal with angle 30 degrees and 60 degrees. I'm going to be using an equilateral triangle first. I'm going to be using an equilateral triangle. So let's say this is an equilateral triangle. Now, the length of the sides, I want to choose these particular values. You can use any value of your choice. You still always end up with the same result. So I'm going to choose 2 here. Let this be 2 and let this be 2 as well. Equilateral triangle. So automatically, if it is equilateral and sum of all the angles in a triangle is 180 degrees, so that implies that each of them would be divided into 60 degrees each. So if I draw a line of symmetry, right here, and I bisect this triangle into two halves, because it is an equilateral triangle, it means that this side and this side, they will be equal half of each other. So therefore, this angle is going to be 30 degrees, this is going to be 30 degrees, and this is going to be 1, and this is going to be 1. So permit me to extract that triangle out, that right angle triangle. That is not a right angle triangle at all. So if I extract the right angle triangle out, so notice that this side is going to be 1, this side is going to be 2, this angle is going to be 30 degrees, and this angle is going to be 60 degrees. Of course, you have this as a right angle. The only thing we don't have here is x. And so we can use Pythagoras theorem. We know that x squared plus 1 squared will be equal to 2 squared. Yeah, the square of the two other sides will be equal to the square of the hypotenuse. That's your Pythagoras theorem. So if you solve for x here, x will be square root of 2 squared is 4 minus 1 squared, that's 1. So x will be equals to square root of 3. Now we can say that this place, I think I should leave it there. So this is the same thing as square root of 3. Now you can use your SOH CAH TOA. For instance, if you're looking for sine 60 now, Or let's start with sine 30 degrees. Sine 30 degrees. So this is 30 degrees here. What is the opposite of 30 degrees? That is 1. So that is 1 over. And what is the hypotenuse? 2. You can look for cosine 30 degrees as well. Cosine 30 degrees. So from your SOH CAH TOA, that is adjacent divided by hypotenuse. What's the adjacent? Square root of 3. And what is this hypotenuse? 2. So you can evaluate anything that you like here. You can evaluate tan 60. Let me just do tan 60 and get over that. So tan 60, tan is opposite divided by adjacent. So this is 60 degrees. What is opposite? That is square root of 3. What is the adjacent? 1. So tan 60 degrees is basically square root of 3. So this is how you get all of those values. Now let's do another one. We have this time around I'm using isosceles right angle triangle. I want to use isosceles right angle triangle. So in the case of isosceles right angle triangle, so that implies that this side and this side will be the same. Automatically that implies that if this is, of course, the remaining two sum up to be 90 degrees. So this will be 45 degrees and this will be 45 degrees. And these two sides will be the same. So if I say this side is 1 and the length of this side is 1, the only thing we won't know here is y. So we know that square of the hypotenuse is the sum of the square of the remaining guy. So y will be equals to 1 plus 1. So y will be equals to root 2 like that. So this is root 2. And then you can get your whatever is related to 45. For instance, tan 45 degrees, which is opposite divided by adjacent, which is 1 over 1, and that is 1. And realize that in this place, sine 45 degrees is actually the same thing as cos 45 degrees. And that will be equal to 1 over root 2. Yeah, you can rationalize to be the same thing as root 2 over 2. And that is basically all the special angles that I will be discussing in this particular class. So this is the major introduction to trigonometry. And if you watch this video and you take note of everything I've said diligently, then you're on your way to understanding trigonometry proper. If you've enjoyed the class, drop a like and hit the subscription button. I'll see you in the next one.